Solution: maximum velocity in simple harmonic motion if r is the amplitude, which is equal to 0.05 meters, is given by the maximum velocity Vm is equals to omega r, which is replacing omega with 2 pi f times r, the amplitude, which you now have 2 pi times, we are given frequency as 4, and then times by our amplitude, which is 0.05, which you now have our maximum velocity to be 0.4 pi meters per second. Maximum kinetic energy is equal to half mv squared, or half m maximum velocity squared, which you now get half times 1 times, which is the mass, times 0.4 pi squared. Maximum kinetic energy is so therefore 0.8 joules approximately. Example 5. The length of a simple pendulum is 0.36 meters and it is released at an angle of 10 degrees to the vertical. Calculate A, the frequency of vibration, B, speed when the pendulum ball passes through the lowest point of the swing, given that 6 degrees is equals to 0.1044 radians. Solution: A. Since the maximum angular displacement is less than 15 degrees, we can compute the frequency f as follows. F equals to 1 over capital T, that is the period. Then substituting the period inside, we have half pi in bracket square root of 1 over g, which we now get by putting in the values. We have 1 over 2 pi square root of 10 over 0.36, which will now give us 0.83 hours. B. Since the motion of essentially simple harmonic motion, then V mass, that is maximum velocity, is equals to amplitude times the angular velocity omega, which you now have K, that is kinetic F over M. We now substitute the value, have mg over ml in bracket 0.1974, where the effective spring constant K is equals to mg over L. We now have square root of 10 over 0.36 times 0.174, which will now give us 0.33 meters per second. Example 6. A simple pendulum has a period of T of 4.2 seconds. When the pendulum is shortened by 1 meter, the period becomes 3.7 seconds. Calculate 1. The original length of the pendulum. Solution: we are given that a period capital T is equals to 4.2 seconds and the length, normal length, is equals to capital L. The formula for the period is equals to 2 pi square root of 1 over g, L over g, closing brackets. Then replacing the unknown values, we have 4.2, which is our period, equals to 2 pi square root of the length L over g. This will now become our equation 1. The period after the length is shortened by 1 is 3.7 seconds. The length is shortened by 1, therefore the length will be L minus 1. Replacing the unknown values, we have T equal to, we have the formula for period T equals to 2 pi square root of length over g. Then replacing the values, we have that the period t is equal to 3.7 equal to 2 pi square root of the length, which we now have as a L normal original L minus 1 all over G. This will now be our equation 2. Dividing equation 1 by 2, we have 4.2 divided by 3.7 equals to 2 pi divided by 2 pi in bracket square root of length over gravity all over square root of in bracket length minus 1 all over G, which will now give 4.2 over 3.7 equals to square root of L over G all over square root of in bracket L minus 1 all over G close bracket. This will now turn out that the G will cancel out. We have square root of L over G times square root of in bracket G over L minus 1 if L jumps up. We now have square root 4.2 over 3.7 equal to square root of L over square root of L minus 1. Removing the square root to the other side, we have square root of 4.2 squared over 3.7 squared equals to L over L minus 1, which we now have square root of 4.2 as 17.64 over square root of 3.7 will be 13.69, which will now give us L over in bracket L minus 1. Cross multiplying, we have that L 13.69 L equal to 17.64 L minus 1. 13.69 L is equal to 17.64 L minus 17.64. And taking the like times together and the known figure on the other side, we have 17.64 equal to 17.64 L minus 13.69 L. 17.64 will now be equal to 3.95 L. L is equal to 17.64 over 3.95, which will give us 4.46 meters. The original length is therefore 4.46 meters. Example 7. A particle of mass 10 raised to power minus 2 kg is fixed to the tip of the fan blade, which rotates with angular velocity of 10 radians per second. If the radius of the blade is 0.2 meter, what is the centripetal force? Solution. Mass is given as 10 raised to power minus 2 kg. Angular velocity equal to 10 radians per second. The radius of the blade of the fan is 0.2 meters. Velocity is equal to omega r, which is now equal to 100 times 0.2, which will give us 20 meters per second. F is equal to mv squared over r. As we now replace the unknown values, which we now have 10, which is the mass, minus 2, 10 raised to power minus 2 times v squared, which is unknown, all over 0.2. Therefore, 10 raised to power minus 2 times 20 squared, which over 0.2. Our force F is now equal to 20 newtons.